Welcome back, friends and neighbors. Today on our networking video, we are going to ponder the question, what if? Okay, so what we're going to do is go through a series of questions and configuration items for hosts and routers. So our first one is, what if I don't get an IP address? Well, there's a couple of things that can happen here. And this assumes right now no static assignment, no DHCP, nothing. So on the right-hand side, we have what our topology might look like. You just have a PC or a laptop connected to a switch, and you got a link, but no IP address from anywhere. So your routing table would look like the one right below that particular topology diagram. And if you tried to ping anything, you'd probably get, at least from a Windows box, ping transmit failed. And the problem, of course, is that you're trying to contact IP addresses, but you don't have one. So that's a really, really basic problem. So that's the result that we get. Okay, so let's take this just a little farther. A lot of times we'll get the 169.254 address, and lots of folks will tell you, oh, that's a Windows thing, it's an Apple thing. No, it is a standard thing. So RFC 3927 is the dynamic configuration of IP version 4 hosts, linked local addresses. Now, link locals are the ones that are on this network. So anybody that you can contact on your network is able to be contacted via your link local address. In an IP version 4, we don't really think about it that much, because we get a unicast address, your IP address, and that's all we think about. But in IP version 6, it becomes a lot more distinctive. But if we got a 169.254 address, it means that we've got dynamic or auto configuration ready to go. Now, most OSs support this, and a lot of applications actually make use of it. And the whole point is that if you don't get an IP address, but you still need to communicate with somebody over an IP network, 169.254/16 is the address space that all of those nodes that would try to use auto configuration would get. Really low probability that you're going to get an IP address that somebody else has, because it's 65,000 node address space. But that's the basic idea. And if you want to read a little bit more about it, it's in RFC 3927. IP version 6 has its own auto config as well. So I'll just read the quote here. It's therefore beneficial for a host to be able to depend on a useful subnet of IP networking functions even when no address configuration is available. So no static, no DHCP. So, and then it goes on to say this is the 169.254/16 address space. So the routing table, if we got an auto config IP address, your routing table would expand to include that particular IP address space, and then all of the other ones that we previously saw, the loopback, and then the multicast, and of course the broadcast. Now, just for fun, if you look in the upper portion where I've given you the IP config, that FE80, that's a link local unicast address for IP version 6. All right, so can we ping loopback? What happens if we try to ping that? So loopback in this case is 127.0.0.1, and it turns out that you can in fact ping that particular address. So you don't have an IP address of any kind, but you do have a loopback configured, meaning that you have a protocol stack that's in pretty good shape. So testing loopback is a good way just to test to see if you're what we call the protocol stack or your networking is in good shape. Now, it turns out that if you have an IP address, you can actually ping that IP address as well. So here's a question. If I ping either of those two addresses, do I generate traffic? The answer is absolutely not. There's no traffic generated on the network. All right, so let's go to our next possible configuration. What if I have an IP address, but I don't have a gateway configured? So that means that I could talk to anybody on my local area network, anybody via my link local address, but I really can't get off my network. But what if I try anyway? In this case, I've got the topology very, very similar to the one that we looked at earlier. You've got a host, but this time with an IP address connected to a switch. And if you did IP config, you would see what's underneath that topology there. So we go ahead and try ping a node that's not on our network. Remember that ping nodes on our network would be just fine. And we get ping transmit failed. Well, why is that? Well, if I need to communicate with somebody off my network, friends and neighbors, what's the first thing we do? We process our host routing table. And when we process our host routing table, we find out we need a default gateway. If you don't have a default gateway, everybody out of the pool. It doesn't work. So we can't do it. So that's why we get ping transmit failed. Now, every once in a while, historically, we have seen that sometimes we also get destination unreachable. And that is telling you the same thing. But this is a very recent test that I did, so ping transmit failed is going to be our answer here. Now, what if the gateway is configured, meaning that you put it in your IP version 4 configuration, or you even get an address via DHCP, but the router isn't actually there? So we have a configuration, but the router's not there to answer up. So what happens then? Well, now I go to ping off my network. So I'm on the 101 network, so 192.168.101.1, and I want to ping 192.168.102.1. What happens then? I'm trying to go off my network. So in this case, you can see in the command window output here, I try to ping it, and I get destination host unreachable. But the important thing to look at is, where did this come from? This particular message came from 192.168.101.1. That's me. So I just told myself destination unreachable. And the question is, why? And the answer is that when you tried to communicate with somebody off of your network, what you did was you tried to contact the default gateway. Of course, the default gateway didn't answer up. And the reason that we contact the default gateway is because we need help getting to this node that's not on our network. So in the bottom of this screen, what we're showing you is the ARP traffic. So who am I looking for? I'm looking for 101.254, which is my gateway. But the gateway doesn't answer up, so I get destination host unreachable. It's a little bit different than the previous case. In this case, I thought I could get some help, but my default gateway doesn't answer up. So the traffic in this case is just ARPing for the default gateway. Now, what if I have a default gateway and the default gateway is out there, but it's clueless, meaning that it doesn't really understand very much of the world. So it's misconfigured, or it just hasn't been configured yet. So I get an IP address via static configuration or DHCP. Theoretically, because I have a default gateway, I could get off of my network. But the router isn't told about any other networks, so it only knows about the directly connected. So in this case, the router that's in this particular topology would have one directly connected network, and that would be the one that we're sitting on, 101.0. So what would I get if I tried to ping anybody else? And the answer is an ICMP destination unreachable. Now pay attention here. This is one of the big differences. We just said that we get an ICMP destination unreachable. So if you look in the bottom right, you can see that I tried to ping 102.1 and I get destination host unreachable. And it looks a lot like the one from the previous slide. But it's not, because this one came from 101.254, a router. And that's a router telling you, I don't know how to get there. And this comes to us via an ICMP error message, an ICMP destination unreachable. And this is the example that we have here. So in this case, the 101.254 is sending this back to 101.1, telling you I can't get there, destination unreachable. And because it's an error message, it includes inside the message the original message that caused the error to be generated. So that's what ICMP error messages do. Now here's another what if question. This one's kind of fun. If I point two routers at each other, so we can see that router number 1 is using as a default gateway router number 2, and router number 2 is using as a default gateway router number 1. What happens if we do that? The answer is we get a routing loop, and the ICMP error message that's generated there, ICMP time exceeded. So let's see what happens. If I point two routers to each other, and let's say that we've got a host that says, I want to go to a network on the other side, or I want to go to a network that nobody knows about. Well, the router's response is to process its routing table and get to its default gateway line. So it sends it to, in this case, router number 1 sends to router number 2. Okay, router number 2 says, where are you going? Oh, I don't know where that is. Let me check my default gateway. And it goes down its routing table and says, oh, my default gateway is router number 1, and sends it right back. And so they just bat that back and forth. And they do that until the IP header time to live field gets decremented down to 0. And at that point, an ICMP time exceeded message is generated. And so we can see that this is a type 11 time to live exceeded. And again, it's an error message, so it includes inside the message that caused the error to occur. In this case, it was a ping or an ICMP echo request. What if a host tries to send traffic the wrong way? And in this case, what we mean by that, if we take a look at the host in the middle there that's circled, that host has as a default gateway router number 2. But it's trying to reach a host or a destination on the left-hand side of this topology, all the way back the other way. And so if we think about this, router number 2 would have a static route that says that particular destination network is reachable via R1. Now, wouldn't it make more sense for that host to send this traffic to router number 1 to begin with? Well, the host doesn't know that. You can only pick one default gateway per interface on a particular host. And so in this case, it was configured to go to router number 2. So what happens? Well, when this occurs, we get an ICMP redirect, another error message. So what ends up happening is the router gets this message from that host in the middle and looks at its routing table and says, oh, I have to send it right back out the interface that it came in on. All right, so this gets to our conditions for a redirect. There are 3 things that will cause a redirect to be generated. If you don't answer all 3 of these, the redirect will not be created. So, number 1 is that this packet had to have no source routing information included. Now, I don't know if you knew this, but an IP header can actually be expanded to include the routing hops that you wanted to go by. Most of the time we don't do this. But if you did, that would cause a redirect to not be generated because the host is saying, no, I really wanted to use that pathway. A second requirement is that the new forwarding router, in this case R1, has to be on the same network as the source host, and it was. And the third one is that the router that received this, router number 2, has to send it out the same interface it came in, and that's actually what happened. And that causes the redirect to be generated. And so we've got another case of an error message. So this one's a type 5. And of course, we include a portion of the original message that caused the redirect to be generated. Well, that's it. Thanks for watching. This was a what if packet adventure. I hope you found it entertaining. Hey, like and subscribe. We're trying to figure out what folks need and what you're interested in. I'll see you next time. And until then, may your packets always reach their destinations.